The workshop is meant to be for 8 hours, so we are going to try to zip it into 4. So I'm going to talk really fast. Maybe I won't show some of the videos or maybe some of the examples, but you can do it at your home. So if you really like it, I'm going to show you where to buy all this stuff because you need some pieces of carbon, okay? So the thing is that I want to show you everything that I show in 8 hours, but in 4. So I'm going to move really fast, okay? But, well, I'm going to show. So any other facts? Because you are here? Okay, that's the university card or the university card? Yeah. The uni card? Okay, cool. So every morning or every evening you just beep and then pass. Okay.
I like this, yes.
Can you buy stuff with this? No.
No.
It's not an e-wallet.
No.
Okay. Well. Well, we are going to wait 3 more minutes, so we are going to start 10:05, okay? If you want more candies here, you will take it.
If you want to have another transport card,
Okay.
or the railway system.
What is that?
Railway system.
Railway. Nice. You are currently using this car?
Yes,
to
I'm
travel?
in the Moscow region, and I travel from Moscow to Moscow every day, so I have the transport card.
Do you know which type of car this is one?
I don't know.
Nothing? Okay, we'll try. What we're going to do is try to see what is going on inside here, just to take a look, and then it's all yours. Okay, cool. So we have Troika card, some railway card, and the uni card. We have many stuff to work on.
Железнодорожная это с чипом она, да?
Знаете, оно на метро вроде как, да.
Ну, чипа там есть контакт? Похоже, Ява как Джейкоб.
Sorry? In another language?
Извините, я могу вам дать посмотреть. Я так не могу набраться.
Нет. I think that is not Yawa.
It's not RFID?
No, it's. I think that is Yawa card, Jacob.
It's a Jacob card.
No, it's not Jacob.
It's not a Jacob. Well, we are going to try to take a look.
Now, will talk about personal.
Yep, it's right here.
Can I look here?
Yeah? It's my lady, you know? Traded as yeah, it's kind of expensive piece of armor, so. But we're going to
compare.
Ah.
My Chinese.
this is a Chinese one. Yeah, but
It's Chinese too.
No.
It's original.
It's original, yeah.
I have some.
Where did you buy it? From
What?
From this guy from the forum? It's called
From eBay.
from eBay. Okay. Yeah, it's very similar.
I have some experience, but I don't
Okay, yeah, maybe later. Yeah. ¿Empezamos a hablar? Okay, so let's start. Okay? Well, welcome to the RFID Security Workshop. I'm Nahuel. Yeah, it's pretty hard to pronounce it. Nahuel, it's from Argentina. So, we are going to move really fast because the workshop is going to be for 8 hours. So we are going to try to zip it the entire workshop. And we are going to do some break at 12 for only 10 to 15 minutes, not more, okay? So try to be here because I'm going to start and then go and move through the slides. So I work at an insurance company in Argentina. That's my daytime work. I am a security specialist. I'm enthusiastic because I really like all stuff related to security. I have discovered many vulnerabilities in open source software and other kind of software like WebSense, OSIM, Cacti. I'm a really lover of gadgets and electronics, so you have many here, so I really like it. I have a CH, CompTIA, C++, and many other kind of licenses. So that's my LinkedIn and my site and other kind of links over there. I don't know if the slides are going to be online. Yeah, maybe they're going to be online soon. So you can have all the links and all this stuff that I want to show you over there, so you can use them later. Okay? So we're going to start with a little motto, with a little motivation from the Hacker Ethic and Spirit of Information Age. I don't know if you know, Pega Jimenez is a writer. So we are going to start with 3 main models. So we are here because we are enthusiastic, passionate, and we really enjoy what we are doing. Yeah? Well, I think so. Because of your faces here. So, because we are very creative, yeah? Because we need to have a lot of creativity to hack into the systems, to think in another way, trying to hack the system. And we should share our skills and our knowledge, okay? So, well, model version 2, hack the system. We're going to try to do the same as the guy over there. So, well, let's start. Let's start reviewing the agenda, so if you don't really like it, you can just go. Take a switch and go. So, we're going to talk about what is true about RFID, what is not true about RFID. We're going to see real-life examples. Everywhere we are all surrounded with RFID systems and NFC. We're going to know the difference between RFID and NFC later. We are going to check some RFID hardware, then we are going to review the lib and NFC, and then we are going to check what is the Proxmark. Yeah? It's a really good piece of hardware there. So we are going to take a look into tags, high frequency and low frequency tags. Yeah? Here we have some high frequency tags, and the one from the uni, where is it? It's right here. I believe it's a low frequency card, so we're going to try to see the difference between them. Then we are going to move into the MyFair Classic tag, so it's a very well-known card, very deployed in many different countries. And by the end of the class, we are going to move really fast, and we are going to review some cases in real life. So, and then by the end of all the presentation, you are going to have all the resources and many other links, I don't know, to buy all this stuff, to get somewhere else to see. Okay? You like it? It's okay? Well. So we're going to go inside the presentation, so it's bored, but it's necessary, okay? So don't get sleep. So what is true about RFID? Well, RFID is radio frequency identification, okay? It's a generic term to describe a system that transmits its identity to another system, maybe a little system, maybe an embedded system, transmitting its unique identity number, okay? Wirelessly, okay? If you are trying to access to the university, you don't need to put your card inside some kind of reader. It just can be a few centimeters away from the reader, and it just works. Okay? So that's RFID. It's a generic term. It will, well, as I said, it will work in a few centimeters. Okay? It depends. It will depend on the frequency. We're going to review that later. Okay, so what's the typical RFID deployment? Consists of a microchip attached to a radio antenna. Okay, that's what is inside the card. Okay, so to retrieve the information inside the card, you need a reader, okay? And the reader passes the information of the card to a backend, for example, okay? Maybe that backend and the reader, it's a unique system. For example, I don't know, the pedestrian barrier in the metro, for example. It's only a big system inside it. Maybe it's transmitting some kind of statistical information to a main system over there, whatever. So, okay, we are going to introduce some terms like collision. Some problems with RFID are collisions, because if you have, for example, maybe it happens to you, if you have two different cards in your wallet and try to identify to a system, maybe they collide, okay? So there is a collision, okay? So that's the first term we're going to talk about, collision. That's a collision between the cards, okay? And maybe there are collisions between readers, because if you have two different readers around, for example, this room, and those readers are trying to read the same card, maybe there's a collision between them. So you have to manage both different collisions between cards and between readers. Some problems, okay? Maybe you have other problems in RFID stuff, like low computing power, because you have very small pieces of hardware trying to talk to the cards, okay? They are little arms, for example, little Arduino's chips trying to talk to the cards. So you have very low power over there. For example, there is no real-time clocks on the tags. Maybe right now we have some tags with real-time clocks and very good computing power inside them, but the most common tags like these ones are very cheap and no real-time clocks over here. But random number generators, that's the main problems here. Critical time requirements, because you need to, the reader and the tag need to talk themselves, so they have to keep a very good timing, okay? So there are some problems in RFID. Low bandwidth. Okay, so we also talk about NFC. NFC is an open platform technology, yeah? It's a standard that it's going on right now. It's not very full standardized. Some industries are using NFC and trying to improve it. So it's growing up. It's a subset of RFID. Okay, so we have the RFID world and the NFC world. Remember that. So, and remember the working operation of NFC. It's 1356 megahertz. That's high frequency. Okay, remember all those terms. Because of the frequency, it will work in short ranges. Okay, a few centimeters, maybe 5, 3, not more than that. Okay, so what does NFC provide? It provides card emulation. Okay, you can emulate a tag with a device. That's a good idea. We have peer-to-peer. You can communicate. You can do some communication between two different devices, like I don't know, two different cell phones with NFC, talking to themselves, transmitting, for example, a picture. Yeah, you want that?
Can you take me?
Yeah.
Micro.
I have to use the microphone? Okay. Okay, so we have card emulation, peer-to-peer, and reader-writer mode, that it's the common one, okay? I have the card, there is the reader, and they are going to try to communicate each other. So, well, It's all about NFC here. We have the NFC IP2 and the NFC standard over there. So you can take a look at this slide later, okay? It's the NFC standard. So, as I said a few minutes ago, what's the NFC Forum mission? Define and stabilize the technology. So the technology, the NFC standard, it's not fully standardized and it's not fully used. So they have to ensure interoperability among devices and services. Of course, encourage other guys to the development of products within or following NFC Forum standard. Educate the market to use it, of course, and ensure that if someone I don't know, is working with NFC and there is an NFC logo in their product, ensure that this product is really following all the specs in all papers. And promote user end usage. Hey, use NFC. Yeah, we're going to use it in a couple of months or years, I don't know. Okay, right now we are going to talk about what is not true about RFID. Yep. Well, what is that? You know? Do you know what is that? It's a barcode reader, okay? Barcodes are not RFID, you know, because you need some kind of laser trying to read all those black lines and white lines over there, okay? That is not true RFID. So yeah, we know that. Yep, we all know that barcodes are not RFID. Well, what's that? Magnetic stripes. So a card with a magnetic stripe is not RFID either. Yeah, we all know, of course. Maybe you might have an RFID tag with a magnetic stripe over there, but it's a magnetic stripe card and an NFC tag, okay? Well, and there is a chip over there. And of course, you have to put it inside a reader, and the reader will make contact with the card. So it's not RFID either, okay? So have you ever seen this kind of hardwares online in DealExtreme? Or maybe Dino Direct, all those Chinese stuffs? It said, yeah, I can copy any card. I can duplicate any tag between those frequencies. Yeah, it's about, I don't know, it's $50, I don't know. But I can clone any card, so everybody is going to buy this to clone, for example, the Troika card, and it won't work because of the frequency and all other stuff that we're going to see. So, but yeah, it's bullshit and more bullshit. You can buy to clone, for example, maybe this type of cards like the Uni. Maybe you can clone these type of cards with this piece of shit. So, but you can use some kind of professional stuff like Proxmark that we're going to view later, okay? So it's kind of bullshit, but well, not that much. It can copy this kind of cards. And there is another one. I'm fully featured. I will copy my fair cards. Please use it in a legal way. Chinese people are really funny. Okay, yeah, this is bullshit too. It won't work. Just don't buy it. So, real life examples. Yeah, we have, for example, we have, for example, electronic passports behind some labels. We have many. We have for example, there's the chip and there's the antenna to get into buses and to track, for example, some kind of mercancy, I don't know. So it's almost everywhere. For example, in your clothes, maybe you are being tracked with the label in your clothes to enter buildings in your new Visa card. It's almost everywhere, yeah? So, for example, I'm here since Sunday, so I just took a walk around the city and took some photos of a few stuff I saw in the metropolitan area. So what is that? I don't be sure.
It's ElixNet. They call it self-ElixNet system. If you want, maybe have their card too.
So, but what does it do? I don't know.
You can transfer pay back for your internet, cell phone.
Ah, it's like an e-wallet, or
Something like that.
do you have the card for that
I
system?
will take a look.
Okay. So, what is this? A bathroom with NFC? Yeah, it's really. I don't know what it's that because it's Russian, but it's a bathroom with NFC. I don't know. So, and what is this? You know it? It's to rent bikes. You have the card there. We have many cards to try to crack. This is used to rent bikes. That's what I thought. I don't know. Yeah? Do you have one card for this system? No. No? Okay. And this is another NFC-enabled device. I don't know what this is. You know? Okay. Can you see the logo there, NFC? I have the same reader over here. You know? So, well, we have many real-life examples. So that's why we are here. That's what I believe. Okay, so we're going to review the hard one. So, 3 basic components, okay? We have the transponder, that's the RFID tag. We have the antenna, okay? And the transceiver. Okay, so when the RFID tag passes through the field of the reader, it will activate the tag, yep, and the reader will try to communicate, yep. That's the basic idea. And so we have 2 different types of tags. We have the active tags that have their own power, yep. This one, for example, these type of cards are passive because there is no power inside it. Okay, there is no battery inside it. So we are going to review the differences between active and passives. So, because they are using electromagnetic waves, they are classified as radio systems. So they have different frequencies to work with. So we have to see them. So we are going to use different ranges. We are going to see the low frequency and the high frequency. And maybe the ultra high frequency tags, but we are going to go very quick on that. So in this slide, you will have the low frequency description, for example, the operating range and some applications. For example, you are going to use the low frequency tags for animal tracking, okay? For, I don't know, post applications. And why they are very common in animal and farm locations, because they work very well around water and, I don't know, metal products, mag, and all kind of those farm stuff. So that's why the low frequency band is being used on those applications. And then we have the high frequency, yeah? Remember 1356 megahertz, that's the NFC frequency. Okay, so it will work in a few centimeters away the reader from the tag. There are smart cards. For example, they are very common in transportation systems in all the entire world. The benefits, they are very low cost, okay? Because they are very cheap to manufacture, okay? And then we have ultra high frequency and microwaves and all that stuff. So this is the frequency ranges of the RFID hardware. Okay, we are good right now? We are good? Okay? So, it's all about tags, okay? We have many tags here. You gave me a lot of them. So we have many tags in our pockets, and so it's all about tags. Yeah, it's very, very teeny. I have one very teeny tag here. If you want to take a look later, you can just come and take a look. They are very, very teeny, just like a coin. So, remember we have active and passive tags, okay? So, active tags. They are equipped with a battery inside just to power their circuitry, okay? The most active RFID tags operate in ultra-high frequency because they need an own power source just to go up and transmit its ID, for example, okay? So features of active. We are going there. Longest communication range, yeah, because it has, they have their own power source, so they can communicate in large ranges, okay? Because they operate also in ultra-high frequency, maybe, I don't know, 2 meters from the tag to the reader, so that's cool. But you need a power source in the card, okay? For example, they have more data bandwidth, okay? That's because of its own power source. Okay, so it's not all good stuff in active RFID tags. For example, the lifetime of the tag, because of the battery, it's shorter than this one, for example. That, okay? Because of the battery. You need to replace it or just dispose it, okay? They are more expensive because of the circuitry inside the card, okay? Well, they are physically larger, so maybe you need some, I don't know, stickers to put in your products, and you don't want some kind of big stuff attached to a product you are selling, okay? So those are some disadvantages there. Okay, now we are going to review the passive RFID tags. So how do they work? They don't have their own power source to transmit the information. So it's all about variation of energy between the reader and the tag. So the tag enters the magnetic field that the reader is emitting, okay? And then by load modulation of that energy, the card will try to communicate with the reader. It's kind of easy. It works like a transformer, you know? So it will do a variation of energy to talk to the reader, for example. Okay? Yeah, it's really easy. So the reader sends, I don't know, this kind of signal, and by doing the load modulation, changing the resistance of the card, will try to talk to the reader. It's very easy. And it's all done by these disposable cards, for example. Yeah? It's magic. Yeah, I know, it's magic. So it's all not good news about passive RFID tags. Short distances, they only work in very short distances, like 5 centimeters or 1 centimeter, not more than that. For example, we have many limits to, I don't know, to implement some kind of sensors inside the tag, I don't know, because they don't have their own power source to feed some kind of circuitry inside it. And advantages, well, we talked a lot of the advantages of passive cards. So yeah, there are many different shapes of cards. So you're, for example, here, these are the disposable ones. These are plastic cards. Cool. We're going to review it later. And the chip is really, really teeny. Yeah? We have many other kind of tags. For example, that's a rice, you know. So it's really, really teeny. And some very crazy guy just inserted in their own hands just to identify the system like this, beep, with his own hands. Yeah, very. That's a human ID implant. It's really cool to. Yep, they are all high frequency. Yep, that's okay. Yeah, because of the antenna, you know, it's really the antenna. It's smaller than the low frequency ones. So you have space to implement a high frequency antenna in a very teeny space like that. Okay, many other different shapes of tags. For example, you can buy this tag assortment from Adafruit. It's, I don't know about regulations here and customs while trying to buy some stuff from another country. Is it easy to get some stuff from another country, like China or the States? Yeah? Yeah? Cool. So you can buy this tag assortment. It's kind of $10, maybe less. So you can start playing with these cards. Ah, cool. Nice. Maybe that's a low frequency tag. Maybe we can try it later. Okay. So we have many. For example, this one is from Kodak. It's a capsule that you are going to swallow, and then the capsule will try to track what you are eating. I don't know. Follow or monitor patients' medication history, if the patient is really taking their medicine or not. Many different crazy applications of RFID stuff. Okay, so low frequency tags. They are typically operating at 125 kilohertz. That's the typical operation frequency of those tags. Between 125 kilohertz to 134 kilohertz. That's the range. Okay. As I said, it's fairly easy to communicate with these tags in a very very difficult environment, like, I don't know, with metal content, with, I don't know, in an environment full with mud and pigs and all those stuff. So they are very good. They work really good in those type of environments. Sorry. They are mostly used in access control systems. That's the main application of the low frequency tags, like the ones that we used to access some buildings, or I don't know, the uni and all those stuff. For example, we have Proxcard 2 from HID. HID is the most known company issuing this kind of tags. As you can see here, they have the MicroProx tag, the Indala Frex card, the HiTag 2 card. So there are many different cards from HID. So that's all for low frequency tags. Now we are going to move inside the high frequency tags. And we are going to talk about this ISO, the 14443. Try to remember this ISO because it's a very well-known standard that NFC is based on. So this standard will describe the modulation that we talked. Remember the modulation between the reader and the tag? Okay. It will describe the exact timing about that modulation and the transmission protocols that are going to be used in order to transmit all the data inside the cards. Okay? So you can read it's fairly easy to read. It's not, I don't know, TCP or another kind of standard. But there are two different types, type A and B. We are going to move inside the type A of this ISO. Remember the collision. This this ISO describes how to manage the anti-collision system, trying to set a way to prevent the collision between, for example, two different cards. So it will describe how to manage the anti-collision phase. It's the first phase that the card will do when it enters in the magnetic field of the reader. Okay, that's the first stage, if you want to say. So we are going to introduce other terms like ATQA, SAC, and ATS. They are values being used to identify, for example, the manufacturer of the card, the tag type, if it's a MIFARE, for example, if it's a MIFARE Plus, if it's a MIFARE Ultralight, like the ones being used at the metro here in Moscow. So we are going to use those values for that. So we have many different high-frequency tags, like the I-class card from HID again. We have the MIFARE class 1K, that's the most common one, from NXP, that's the manufacturer. We have the Sony Felica cards, for example, the MIFARE Plus that is being used right now for the Troika card. So we're going to see the properties of those little cards. Okay, so how are you right now? We are fine? Yep. Any questions right here? We can just go. We can move on, right? Yeah. Nice. Yeah, wake up, man. Come on. So, well, we need software to try to communicate with these tags using our computers, trying to, well, hack the tag or some system you are trying to understand. So let's see what is being used to talk with this type of cards. So we have libNFC. If you have connection here, I don't know if there is a Wi-Fi connection here, welcome. Yeah? Okay. You can try to download the library and try to compile it. I don't know if you have Linux or OS X. It's fairly easy to compile the library. I have the pre-compiled version of the library for Windows, Trojan free. So you can try to download it while we are talking, and then I can borrow you some kind of those hardware I have here, just you can try it. Okay. So what is libNFC? It's an open source, library being used for NFC tags. Okay. So this is what the page says. libNFC is the first Libre low-level NFC SDK for programmer and an API, released under GNU. Okay, it's an open source library being used to use some kind of dongles or readers using our computer. Okay, and to try to read those NFC tags. You can download it from here or just Google it. It's almost the first hit, okay? It's now under the NFC tools. First, the libNFC was a standalone library, and now it's under the NFC tools. It englobes some many other tools surrounding NFC, so it's good. So you can try to download it and try to compile it, and then we can try some of this hardware here. Okay, so this is what we are going to use in order to try to hack these cards, for example. So, operating system supported. Okay, Mac, of course. Linux, well, Windows. I don't know if it's easy to compile it under Windows. Maybe using Cygwin or some sort of those compilation or kind of systems. Yeah, true. It really compiles out of the box. Try it. This library supports many different type of hardware. like dongles that I have here, for example. This is a little dongle with the antenna on the PCB attached here. So this is a dongle. We are going to see which type of dongles does the library support, and flat or OEM devices like this one, this kind of readers. So we're going to move on. We are on time? Yeah. Yeah, we are good. So these are the most devices that the libnfc will work with. The dongle here, it is called SSL 3711. It's the most common dongle that you are going to use to communicate with the libnfc to the tags. Okay, so it's very, very compatible with this library. So if you're going to buy some kind of reader, I recommend you this SSL 3711. This is from, I don't know, from a vendor called, I don't know the name. Later I can show you where's the vendor. You can also get some Chinese dongles following the same. Well, the NFC controller, that's the chip that the reader is using, is called PN533, okay? Remember that name of the chip. That's the chip that the library will work with, okay? SSM, sorry. That's the manufacturer, SSM Microsystems, okay? You can buy them over there. And then the flat readers like this one is called ACR 122U or U101, I don't know. This one is U82. This one will work also with libnfc. So if you are going to buy, I recommend you, if you're going to buy some kind of devices to work with this one, or maybe this one is better, okay? So this is fully compatible, for example, with OS X and Linux. So this one, the SSL, they are kind of the same, you know, but this one is very, very compatible with libnfc, with Linux. It will detect Linux, for example, or OS X. It detects immediately this dongle. So this one is the very best. Remember the chip inside. If you are going to buy it, remember that you have to ask for this chip, the PN533. All devices working with PN533 will work with libnfc. So, and for example, this one here, the flat one, inside has the PN532, also compatible with libnfc. So they are kind of the same. So, okay, we need libUSB in order to communicate with first with the dongle, and then the dongle will communicate using libnfc to the tags. Okay, so for example, this kind of dongles or readers will work either with libUSB, you have to download it and install it, or with PCSC Lite. That's you need as a pre-requirement in order to have all the systems working, okay? So you have to compile libnfc or PCSC Lite and then libnfc. So first the kernel or the operating system will talk to the dongle using libUSB or PCSC, and then the libnfc will do it work, okay? So the readers, the SSL 3711, that's the reader. The one I have here is without the shield. It's the same. I have more here. If you're going to install right now the libnfc, I can give you one just to to try to see if it's working. Here, it's the dongle, the SSL 3711. Okay? When you are going to, while trying to compile libnfc, remember to use /configure. You're going to first configure the library and then make, well, you are familiar with all those commands. With drivers, pn353x USB, remember the libusb, so we are going to compile the libnfc using that driver, or for example, in order to use this one, we need to use the PCSC driver, okay? So that's a tip in order to correctly compile libnfc. So we are good right now? Yep. Yeah, of course. You want to write it down?
Yeah.
Well, I can wait. Maybe a question? No? The slides will be available at the site, so
Okay.
it's okay? Okay. Okay, so this is showtime. We're going to see some libnfc examples. So, I will show you how easy it is to use this standard. I will try to use all your cards, okay? So we can try to figure out which type of cards are we dealing with. So, can you read from the back of the room? Yeah, it's okay? Okay? Yeah? Okay, so as it says on the slide, it's fairly easy to see what the libnfc is giving us. So we're going to type NFC, tap, and see what's going on there when we have the libnfc already compiled. So I'm going to attach the SSL 3711 dongle here. I don't have enough space. I have many devices over the desk. And we are talking about radio frequency stuff, so maybe it will be a kind of a mess here. Well, we are going to try to use the Troika card with the NFC library, so we are going to try to take a look. So, NFC, tap. Okay, so when you manage to compile the NFC tag, you will have these kind of commands enabled. For example, the NFC anti-call. This teeny piece of software will try to do the anti-collision phase. Remember the anti-collision phase? When the tag is doing its first phase to the reader, okay? It will try to do the anti-collision phase. For example, the NFC list will try to list all your dongles connected to the computer. For example, this one, NFC MF Ultralight, will try to work with, for example, this type of cards that are micro ultralight cards. So you have many different commands in libnfc to start working with. It's open source, so you can take a look at the code. It's fairly easy to read, and you can then make your own programs just to, I don't know, take some piece of MFC ultralight to, I don't know, write inside some part of the memory of these type of cards, well, whatever you want, because it's open source and that's the idea. So, I will not put the card near the reader and try to list. Oops, no device found. That's not maybe because it's attached to the virtual machine? Yeah. And you see it's connected to the virtual machine. That's why the Mac is not recognized. Let's try it again. Hey, hooray. There. So, the NFC device was successfully recognized, so the PM 533 was open. Yeah. Oh, sorry. Okay. Sorry. So the NFC library is really working. The dongle is really being recognized by the operating system. So we are good right now. It's only listing the device. So I'm going to put the card near the antenna and try to again list. Okay. So here we have an answer. We have found a passive target. That's a passive tag. That's a historical card. Okay, it's a passive one. Now we are learning about the card. It's a passive one. Yeah, it hasn't got a battery inside. Yeah, or no? We already know it. Remember those ATQA, UID, and SAC names from the manufacturer stuff? Remember that? Okay, so here we have the response from the ATQA command. It's number 2. We are going to discuss it later, trying to identify which type of card we are dealing with. We have the UID, the internal UID. It's a 4-byte UID. Okay, so we are getting closer to the type of the card. MIFARE cards are most common. It's They are using 4 to 7 bytes of UID stuff. So maybe it's a MIFARE card, and because of the number 2, we are going to see that it's a MIFARE Plus. Yeah, and the SAC it's the number 18. So we are dealing with a MIFARE Plus card. So we are going to try to run the anti-collision phase, trying to see if it's really. Yep. The anti-collision phase worked. So, for example, that's again the answer found tag with the same UID. Yeah, we have the same UID over there, the same ATQA, and the same tag. So it's all working right now. Okay, so NFC library is really working. You can try to download it right now and compile it, and I will give you one of these tokens in order to. This is a workshop. You have to work. Not only me, but well, whatever. So this is all the examples of libNFC. If you have any other questions later, you can just chat me later. Okay. Sorry. Okay, so we dealt with libNFC and all those dongles and flat readers, and now we are going to move inside the Proxmark world. Yeah, that's the Spartan chip. It's very powerful. So, what is the? I have my own little lady here. This one is the Proxmark. So what exactly is the Proxmark? So it's a device that was developed by a guy called Jonathan Westhughes, I don't know how to pronounce it, that will enable you to sniff a channel at the communication between a tag and a reader in both ways. You can't do that with those kind of chip readers. So that's why this kind of devices, it's a little expensive, more expensive. So then you can read, write, emulate, and clone RFID tags. You can do whatever you want inside this piece of hardware. So why did he develop this piece of hardware? Because he wanted to look at the communication between my fare cards, like the Troika, for example, and a reader. He wanted to understand what was going on between that communication. Okay, so he's an electronics engineer, I know, and he just developed the Proxmark. And you can also program whatever you want inside this kind of hardware. So he firstly made an implementation of the ISO. Remember the 14443 ISO type A inside this piece of hardware. Why? Because my fare cards talked in that standard. Okay, so by the use of his own piece of hardware and his own piece of software, he tried to sniff the channel and try to understand what was going on there. And of course, his findings were exposed to the public in a very good paper called "A Practical Attack on MyFair Classic." I believe I have the paper here if you want to read it, or if you want to take a copy, or you can download it. I don't know if it's here. A Practical Attack. Yep. It's not very long, and it's full of information of his research. And that was the start phase for every other single research between or regarding this kind of tags and readers. Okay? We have to leave. No. So that's a picture of the board. You can just take a look at the site. This is the very first site where all the pictures and the schematics. It's open source hardware too, so you can build yourself a piece of this. If you have good hands to solder this, I don't know. Or maybe you can just contact a Chinese guy. He will do it for you. Okay, that's an Atmel chip where you can try to make your own programs and compile it. And that's the XPGA chip that will do all the entire work. That's why, because of this chip, that's why this kind of hardware is kind of expensive. For example, you have the naked Proxmark. I don't know if it's updated, but it's $229. So it's kind of expensive piece of hardware. These kind of dongles are about 35 USD. So compared with 229, but you can do very good stuff with this kind of hardware. If you want the enclosed Proxmark, for about $170, you can have the plastic. So it's fairly expensive. It's a kind of expensive plastic. They are using a kind of expensive plastic there because it's really, really expensive. So I recommend you to, if you are going to buy it, try to buy this one. Or I'm going to talk about the forum. There is a forum regarding Proxmark. There is a Chinese guy developing this kind of hardware. It's very good, so you can try it. And the Proxmark comes with no antenna, so it's only this PCB, okay, with all those chips and circuitry here. So if you are going to try to deal with low frequency tags, you have to buy the low frequency antenna for $60 or the high frequency antennas. I can show you. For example, this is not a CD. It's a low frequency antenna that they are selling. Okay, and here, well, I am going to show you later the other one. It's for the high frequency tags. Okay, so in order to get some, in order to use the system, you need to buy the Proxmark and an antenna, both of them, or I don't know if you are going to try to understand what is going on with the Troika card or these kind of MyFair ultralight cards. You need to only buy the high frequency because they are high frequency tags. Okay. Sorry? No. Okay, so that's the low frequency antenna, and that's the high frequency antenna, all made in a PCB-like shape. So they are pretty strong. So you can fly from Argentina to Moscow, and they are okay. Well, I mentioned the forum. Yes, we have forum regarding Proxmark, and some guys developed their own antennas. For example, the one on your left, it's a low frequency one. It's homemade. You can build your own antenna. I don't know. And this one, for example, is a high frequency antenna. You can just make your own antenna with some piece of coil, okay? It's a coil. So, we are going to see the commands inside the Proxmark. One of them is hardware tune. So we are going to try to tune the antenna so if it's working or not. So trying to see if the antenna is really tuned to speak with a low frequency tag or a high frequency tag. Okay, so as I said, the Proxmark is fully customizable. Okay, you can customize the software inside the Proxmark in wherever way you want. So you need to flash it in order to have the new software inside it. So, for example, here we have some commands for high frequency. For example, some commands implementing the 14443A standard, the V1, another ISO standard. For example, trying to work with I-class tags. So, and the tune one, continuously measure high frequency antenna timing, trying to see if the antenna is well tuned and is well made or not. Okay, these one are some of the commands inside. And of course, the firmware has been very, very, very modified. So you can, of course, it's open source too, so you can build your own piece of software inside it, you can modify it, you can do whatever you want. So while trying to deal with low frequency, you can, I don't know, deal with HID, RFID tags. We are going to see this kind of commands. You can try to read an LFC ID only tag, like the ones you are using, for example, to access a building. They are only ID RFID tags. And many other, for example, to simulate. We are going to see them in a few slides more. So here we have some MyFair commands. For example, I don't know, to sniff the card to the reader communication in order to sniff what is going on between the card, the MyFair type card, and the reader, in both ways, okay? While the card is communicating to the reader and while the reader is trying to send some command to the chip inside the card. So it's a very good piece of hardware. So if something went wrong while trying to remember, I don't know if you're familiar with this kind of flashing stuff, but if something went wrong, I don't know, if you are trying to update the software inside the Proxmark and, I don't know, light goes off and the procedure just cut off in the middle of the entire uploading. So you will need a JTAG interface like the J-Link. You can find this kind of hardware in the Sega webpage or again in another Chinese or in eBay store. So you can buy it in order to try to recover the software inside the Proxmark. Okay, so if you I don't know, if you did something that break the Proxmark, you will have to run the JTAG recovery procedure. There is a cool post in the Proxmark forum that will help you really good within this procedure. Okay, so that's why the forum it's really good, because I don't know, some guy said, oh, I have bricked my Proxmark. What can I do? I have to, I don't know, use it as a I don't know, as a thing over my desk, or can I recover it? No, yeah, you can recover it using this JTAG. Oh yeah, where I can buy it? Ah, right here. Oh, what is the procedure? Oh, I did this, or I did then. So you can read this cool post in order to run this procedure. I never run it because I never brick I've never bricked the Proxmark, but who knows, while trying to deal with this stuff. So this is the community forum. You are going to find a lot of resources inside the forum. You just go to the proxmark.org webpage and then go to the forum link. You'll find many different documents in the files section. For example, the different hardware revisions of the Proxmark, variations of the software inside it, some photos of people modifying the hardware. Remember that it's open hardware too. So I know some guys building an LS with a Proxmark with an LCD screen on it, so they can just move around and sniff communications on the fly. So it's really cool. So you have many different resources there. Okay, so I'm going to show you the Proxmark. Okay, so here's the Proxmark. This is the lady. Okay, any questions right here? No? Okay, so I will disconnect the dongle. Okay. This time I will use the Windows virtual machine. Okay, the low frequency antenna attached to the Proxmark. I don't know why my keyboard is not responding. Yes, I need to unmute this box. Okay, here. Okay. Yeah, it's in Spanish. Okay. Can you read from back of the room? Yeah? Can you read? Nice. So, the connected units, of course, only one. It's the Proxmark. So we're going to run the help. Okay, this help. For example, we have the HF commands, hardware commands, and LF commands. For example, let's run the hardware command and let's try to tune the antenna. Okay, it's trying to measure the antenna characteristics. Please wait. It's working. Believe me. Okay. Of course, your HF antenna is usable because it's not attached. Yeah, we're going. Okay, and you can you have to check the voltage in the antenna in order to see if it's working, if it's really working. So this antenna is really working. So we have, it was bought from the site, so it's going okay. So let's see another command. Example HF 14. For example, we have some commands to in order to make this Proxmark to act like a reader. You can use HF14A reader, or for example, if you want to fake a card like, well, not like this one, but an ISO 14443 type A card, you can use the simulator in order to fake only the UID. So you can try to fake a UID using a piece of hardware. That's good. So now we are going to see some characteristics of the Proxmark. Yeah, we can clone and we can emulate a tag with this kind of hardware. So we are going to see how can we run this emulation and this cloning stuff. So what we are going to try to do is to bypass your front door. What do I have here? Okay. This is exactly what is in a picture there. It's a kind of alarm system, yeah, that uses low frequency tag in order to operate and open the door. So I have the key here. Where is it? Here. You have to configure the card to in order to access this kind of system. You have to mark some kind of there is a manual, the operation manual to coordinate the card with the system. So when you can pass, okay? Green light, and then the door is open. So we are going to try to first. What do you want to do first? Do you want to try to emulate the card using the hardware, or you wanna clone the card and have another card that is a clone of the first one? It's the same. We're going to do both schemes of whatever. Emulation first or cloning? Emulation? Okay, so I'm going to try to sniff the card. I don't know, if someone is, I don't know, in the bus with their card in their pocket or in their wallet or something, I'm going to try to sniff it using the antenna, and then I'm going to try to access it using only the Proxmark, okay? Trying to emulate the same UID as the system is recognizing as green, okay? So, let's try. So, you have the command here. It's fairly easy. You have to first watch the type of card. These type of cards are called EM4110X. So these type of cards are supported by the Proxmark. If you download the latest firmware and upload it to the Proxmark, it will support this type of cards. I don't know, if you find another type of card that you want to emulate or clone or whatever you want, you will have to make your own piece of software. But these are very, very common. I bought this from Dino Direct. It's a Chinese free shipping site in the web, and they are very, very common. So okay, we're going to run the first command. We're going to watch for a card, trying to sniff the UID over there, and then we're going to emulate the UID using the antenna, trying to access the system. So it's very, very easy. You're going to see. Okay, so the command is LF EM. I'm going to put the card here. It can be a few centimeters away, you know, but I will just put it here just for a show. So I will use the command LF EM. You have many commands to work with this type of cards. So the one we are going to use right now is MEM 410 X watch. Well, let's pray. Okay, trying to read some samples. Well, you have to yeah, that's all. Sniffed. The ID was sniffed, and the internal ID of the card that it's not the same that the one written here. The internal ID identifying to this system is this one: 3400 ACA 3 ACA 60. So we are going to emulate that UID. So LF EM.
Sorry, can't really pick up full screen.
Yep, sorry. Yeah. You need a bigger font?
Yes.
Sure. Properties. That's okay? Nice. Okay. So, we are going now to try to emulate. So, we have the LF, EM, and EM 41, 0, X sim. Now we're going to try to simulate. Okay, what we're going to try to simulate? The previously extracted UID. That it's, let me check it. It's near here. Here. Oops. Oh, yeah. Holy crap. Well, I have the command here. Let me copy it. You can trust me. Okay. Now again, I will update the font size. Yeah, sure. There. Paste. Okay. So, it's not working. We're going to try to set that up. Please wait. Yeah, it takes some time. Okay, starting emulator. Yellow LED is on. So let's try. Okay, now we are in. Okay, so we have bypassed the front door of someone's house. So it's pretty easy to use a piece of hardware emulating the same tag over there. Of course, you can write your own piece of software in order to run all these sniffing and emulation phase in just one shot, and you can run the Proxmark using an external battery in your pocket. So you can just plug the Proxmark to a pocket battery, and then get the Proxmark in a sniffing phase at the init phase of the Proxmark while it's initiating its own core, and then try to sniff wherever it's near the antenna. So you're I don't know, on the near a house that that owns a reader like this, and you can just hit and poof, and you are in. So it's very easy to run that. So I will show you what I said, but I will show you a video because I don't have an HID type reader, but I have a video bypassing my boss's office door. So, as I said, the Proxmark is able to run in a standalone mode. So I will show you this. That's the HID reader. So that's me in Argentina. It's not a YouTube video. Okay, yeah. The time is working. That's the Proxmark. It's only the laptop. It's only being used in order to power up the Proxmark. Okay, and that's the low frequency antenna attached to it. Okay, you have to press the button for a few seconds in order to have the Proxmark in the standalone mode. Okay. It will turn the other LED on. That's why. That's because the Proxmark is trying to say to you, yes, I'm sniffing right now. So try to. Oh, sorry. Okay, sorry. Yes, I'm ready to sniff a car. So take a look how fast is a HID sniffing. Okay, sniffing, sniffed. That's all. So if you have, I don't know, if you don't have access to a door, and I don't know, some policeman does, you can just move your antenna near his badge and sniff it. It's. Sorry?
We need to know the type of a car.
Yeah, of course. But if you are inside the building and you can see this type of readers, okay, yeah, they are HID. I know how to deal with HID type of cards. They are using HID cards. That's all we know. Well, that's all we need to know in order to sniff it. Okay? So without knowing, okay, I don't know the type of the card, but I know the type of the reader. That's all. So see how easy is the sniffing. Sniffed, that's all. So it's, and then press the button again in order to, okay, beep, and you're in, okay? So it's fairly easy. Yeah, that's me and cat, okay? So it's very, very easy to emulate in standalone mode. You can build your own software to put the, right now we have the Proxmark running in standalone mode only for HID type of cards, okay? If you want to run the standalone mode in order to sniff this type of cards, you need to rebuild the software, okay? Yeah.
Did you use brute force LF card in Proxmark?
Sorry? Brute force?
Brute force in
No, it's not doing any kind of brute force there. It's just sniffing the UID inside the card and then emulating.
some guy in forum write software that use brute force IDs of LF card.
Yeah, you can, yeah, that's a good idea.
Did you use that?
No, I didn't use it, but I know what you are talking about. As you saw, the device is only emulating the UID. So you can try to brute force that UID in every single cycle. So you can try, I don't know, okay, let's try 0000001 UID, nothing, 2, nothing, 3, nothing. Well, run a brute force over that UID. It's kind of long in order to run a brute force, but maybe you're lucky and you got one UID that has access to the system. Okay? You can write A guy from the forum wrote that piece of software, no? I don't know. Okay. So yeah, you can try a brute force over there. So now, what we're going to do is to try to clone the card. So yeah, maybe if we are trying to access, I don't know, some kind of door using all this stuff, a stylish antenna, maybe we are caught by I don't know, some cameras over there. So let's try to sniff the UID and try to use a card that is enabled to being programmed in order to simulate any UID you want, okay? So we are going to try this with the Proxmark. So we already have the UID. So the command is the one right here. I just copy it. I won't write it. Okay, so we are going to use, let me show you in full screen. The card I'm going to use in order to clone the first or the original card is called the T5557 card. There is a chip inside this card that you can program in order to simulate any UID you want, okay? So that is the type of card you need to buy in order to try to clone this type of cards. So this is what I have here. The low frequency, remember that we are using the low frequency antenna. This is a low frequency system, and we are going to use a low frequency tag that will enable us to clone the original one. So I will paste the full command here. Oops. Yeah. Okay, again. Oh. Sometimes you have to disconnect it and connect it back in order to have the full system running again in a good mood. You know, it's open hardware, open source software. It might fail, you know.
Excuse me, which version?
The version, okay, it's, I don't know if it's, no, yeah, hardware version. Okay, it's the 653 from the SVM. That's the version of the software inside. Of the software inside the Proxmark, the version, yeah, it's the one over there, and the full FPGA image is the same version. Okay. Oh, sorry. Yeah, yeah. Please try to remember me that, because I'm going to forget every time I'm going to show you something. Okay. So, okay. So, I'm going to put the programmable card here, right on the antenna. Yeah, it's near all those high frequency tags, but they won't collide, because these type of cards operate at 1356 megahertz, so they can be just there and it will all work. Oh, I didn't show you. Oh, I forgot to show you. First, I will show you that this card, I will use the other one. I have two, okay? Yeah, you need to buy two of everything in order to don't miss. Okay, yeah, let's try. No, it's not working, okay? Because the UID that this card has, it's not the same as the original one. Okay, so I will put the card here. Yeah, it's not working yet. So I will run the command again. Okay, it's pretty easy. Okay, we are going to write this UID inside the card. I'm praying. Okay, written. Okay, now we can just leave all this entire stuff at our home and try to enter the building. For example, I don't know, the IBM building, very well dressed, and then try to do it. Let's try. Okay. Oh shit. Again. Yeah, it's open source, you know. Okay, let's try it again. No, it's not working. Okay, let's try it again. That's why you need 2, 3, or maybe 10. Okay, let's try it again. Yeah, we practiced it. Okay, now we're in. Okay, so you can clone, or you can try to emulate a tab using the Proxmark. Okay, so it's fairly easy. I'm trying to show you how easy it is to run this kind of stuff. I didn't create anything of this. I just bought the hardware, try to download all the stuff and make it run. So that's all. It's very, very easy. Okay, so any questions right now? No?
Is there a way to clone two low frequency cards, which is basically
Oh,
any chance or no chance?
yes. But you won't know which card exactly you are going to clone or to sniff. Because
You can see one time, and another time, and another time.
yeah, you won't know. You won't know because they are because of the anti-collision stuff. You have both, for example, two different low frequency tags together with different UIDs. So if you try to sniff that assortment, I don't know, maybe you are sniffing the first one or maybe the second one. It all depends on the distance between the reader, the position. It will depend. So if you have, I don't know, many cards in your wallet, many LF cards and many HF cards, if someone is trying to sniff it, who the hell knows where it's going to sniff? That's the question? It's okay?
May I ask,
Yeah, sure.
how far can we increase the distance with using an amplifier?
The distance between an LF type of card,
Yes.
no more than, we can try. Let's try. No more than 5, I believe. So let's try. Of course, it will depend on the hardware, of the antenna, of the tag, of the environment. You know, it's all about frequency and radio waves. So you can try to. For example, on the other command, the F and the PM1X watch. Sorry. Watch. So I put the antenna away. Okay, and well, let's use the unicard. Let's try. Okay, let's try to. Can you see it's about 5 centimeters?
And if we will use an amplifier.
An amplifier? It will depend. You can just use an amplifier on the, for example, on the reader side in order to increase the distance between your reader and the antenna. Because of the modulation of the capabilities of the card. Let's see if we can clone this. Let's try this. We have detected that this is a low frequency tag, yeah? Yeah.
sorry, and if the antenna will be more bigger,
If the what?
if the antenna will be more
With-
bigger,
yeah.
more gain,
Yeah.
the distance.
No, you cannot just by increasing the size of the antenna or or I don't know, by amplifying your hardware to increase the distance between your tag and your reader. Because of the protocol itself. Of course, you can try to increase it by, I don't know, 10 centimeters, maybe 15, but no more than that. Because of the protocol itself. Somebody told me yesterday that there was a guy last year here in PHDays that was able to clone or to emulate a card during a CTF here in about 15 or 10 centimeters. So that's the maximum. Because of the frequency, because of the protocol that the card is handling. Well, this is not a EM type of card. Okay. Let's try one more. Okay. You can just push a button in order to finish the phrase. Or apply it. That's the best way to have it working again. Yeah. Okay.
Could I ask?
Yeah.
Is there any other information that we are to clone to get into the building to get through the access system? Is UID enough?
It depends on the system being used by the building. For example, if it's a typical HID that I showed you a few minutes ago, just the card itself only contains a chip that modulates the signal sending its own UID. That's all it does. So yes, another systems, for example, using, I don't know, MyFair or another kind of cards, high frequency tags, maybe they are using, I don't know, some data inside the memory of the chip. But these kind of chips only transmit its own UID, and that's all they do. Okay? Yep. Yeah, it's fairly easy. Yeah, I know. Can you see? It's not the same type of card because it's not being recognized by these kind of readers. So maybe it's an HID type of card. We can try to see if it's. Let's try. Look for again. It goes again. Oh, here point. Yeah, I know. Okay, here, yeah. Okay, low frequency LF HID. Okay, let's try to, for example, demodulate an HID prox card 2. Let's see if it's this kind of card. Let's see. No, it's not. Let's try another column here. Data samples. Okay, we're going to, you can of course use the prox mark in order to try to identify the type of card and try to see what is going on between the reader and the card using a graph. I'm going to show you a little example of this. Okay, reading samples. Okay, done. Let's try to demodulate that. No, it's not a prox card 2 type of card. But for example, you can try to data plot. Let's see. Okay, and you can try to also data plot 100. Oops. Let's see. No. But there you can see the modulation. Can you see that part? That's the card modulating the signal of the reader. Okay, so yeah, it's only a UID type of card. Okay, then you can try to read the manual regarding all these kind of commands of the Proxmark. They are really cool. With this kind of plots, you can identify the zeros and ones being sent by the card. Okay, so try to get some Proxmark on the internet and have it running. Okay. What time is it? It's okay. We are good. Any other question? No? Okay. So I will stay here. So don't do that. This is a picture. I took this picture in Argentina while traveling on a bus. That's a girl with her badge attached to her backpack. So someone with this kind of stuff can just sniff its UID and then try to access the building, say hi to the policeman over there. Yeah, hi, with a tie. You can always pass through the buildings, yeah. Good question. Here, I will show you where is the best way to. Yeah, I have many stuff. Okay. Here I have some RFID blow-in protectors. These are only some kind of slips where you can just put your card inside and then forbidding the access to the card. It's just a Faraday cage, you know the Faraday cage? So it's just building a little Faraday cage for your card. We can try it. You can just pass it. This is closed. And I will show you. How much are those? You can build your own. It's fairly easy. You can try. You can use the paper. It's kind of an aluminium paper used in your kitchen. So you can just build your own in order to build this kind of Faraday cage. You can try to see it. It's fairly easy. And let's try it if it's really working. So for example, I don't want that no one will track my Troika card, so I just put it inside. Let's try again the LibNFC tag. So let's see if it's really working. I don't know, the five pack, the 5 sleeves pack, it's about $10. I don't know, but you can make your own. It's cheaper, and well, let's try. Okay. Remember, let's see if it's working. List. Oops, again, fucking Windows. Sorry. Yeah. Mac, control, please. Okay, yeah, it's working. I'm going to put the card, but with the shield around it, and let's try to list again. No. You see, it's not being recognized. The tag is not being recognized. And now if just remove it, it's being recognized. Okay? So this shield is fairly working. Okay? So that's a good question. If you are kind of crazy, you can use this in order to, okay, I will just do it again. Or you can just keep it inside your pocket and go if someone is, is around you with that kind of antenna, this kind of antenna around you. Okay, yeah.
Iron wallet will help me.
Yeah. Or maybe you can just keep many cards in your wallet, well, whoever knows which card of which card will be recognized by the reader. Okay. Because of the question you wanted, it was a really good question. Yeah. It's yours. Use it.
Can you use Proxmark with Android device?
With Android device,
Yeah.
I saw some guys running the Proxmark on an Android, but it was a Linux operating system inside the cell phone, inside running the Proxmark. I didn't deal with that, but I saw some guys doing it, and it's fairly easy. And there is a manual online, step by step, stating all the necessary steps in order to have it running with the, I don't know, with your cell phone, at the Proxmark attached to your cell phone using an OTP cable. And then you have all those commands in your phone. Just like this.
Do you know about development of GP Hunty, someone about sniffing?
Let me check it
About
out.
sniffing fire on 5 meters.
Where?
The documents, and he said about 5 meters.
Oh shit!
And back.
Yeah. 5 meters away from the. Well, there are crazy guys. Well, that kind of hardware, it's kind of laboratory and very expensive. Yeah, there is a paper there stating that some guys managed to read a MIFARE type token. How many meters?
Three about forward and backward, and 5 only forward.
Only forward. Okay. The reader to the only the reader to the tile, 5 meters, and then a full communication in 3 meters. Well, that's cool. You can try to download that paper. It's really crazy, but with a very laboratory hardware, right? It's kind of expensive.
With some oscilloscope.
Oh, but it's not very homemade hardware. We can't buy that hardware from the Chinese people. Well, yeah. So 3 meters, that's cool. That's cool. Yeah. Well, so the question about the distance between a reader, it's expanded to 3 meters in a MIFARE type tag. Nice one. Okay, so let's move on. What time is it? If you want to do the break right now for 10 or 15 minutes, we can do it. Yeah? You want it? Okay? Well, so it's 10 to 12. 5 minutes after 12, we are starting again, okay? Oh. Well, any questions right now? No? It's okay? It's what you were expecting from the workshop, the class? Yeah?
One small question.
Yeah, sure.
Did you develop?
Translating.
Did you develop smart software? Which tools did you use?
In order to develop the prototype.
Yeah, on-chip development with JTAG interface.
I can only when I'm trying to modify the software inside the Proxmark, I only use a notepad, for example. Yeah, and Sigwin.
No Eclipse, no.
No, nothing. And the Sigwin terminal in order to recompile the entire stuff. That's all.
Yeah.
You only need a C editor. That's all you need. You can use Eclipse or I don't know any other IDE in order to write your own code and recompile it. Okay. Okay, so we are going to move on. Okay, so don't do that. Remember, use your shields, or I don't know, put your cards inside your wallet or beside your bag. Don't let them there, because some Argentinian guy is following you. Okay. So we dealt with low frequency tags. We managed to clone some tags. I showed you a video cloning and emulating an HID type tag. So we are now going to move inside the MyFair world, okay? So I will reconnect this. Let's see. Sure, it's working. Okay. For the people who don't know what the hell is MyFair, it's a trademark from NXP Semiconductors with more than 5 billion smart cards on the market, more than that. So it's very, very well known. So the portfolio of the company, it's kind of big. For example, this kind of tags are being used for automatic fare collection, for access management. You can use the MyFair unique identity number in order to, for example, being used to access a building, like the ones with low frequency, for student cards, in order to, I don't know, physical access to the university, and micropayments, or to, I don't know, to rent a book. Loyalty cards, well, micropayments, that's where we are going to try to hack, the micropayments. Event ticketing in order to access some event, like, I don't know, a concert or a football match, I don't know, wherever. And parking, for example. There is a system in Spain using MyFair 1K for parking for the main city. So it's very, very well deployed. So MyFair Classic 1K was the first IC to be used in high volume public transport ticketing. So that's why we are very interested in MyFair Classic, because the very well-known use in public transport. The first one was in Seoul, in Korea. Okay, so that's the main story of all of this. For example, because of its success in Korea, cities such as São Paulo in Brazil, in Buenos Aires, my country in Argentina, are adopting the MyFair Classic 1K tag in order to give you access to the transportation system. For example, the metro or the subway, that's the way we call the metro, the subway, and buses around the city, and all those kind of transports over there. So that's why we are focusing. Yeah. something? Okay. That's why we are doing some focus on the MyFair 1K type of card. Okay. So it's not just a microcontroller or a tiny chip transmitting its UID. It's more than that. It's a memory. That's the 1K. It's one kilobytes memory. How it's distributed? It's inside the. Let me use this one. Yeah. So how is the memory organized inside this tiny chip? The MyFair 1K chip is this one. You can just pass it over there just to take a look. It's really small. And okay, key features. It's 1 kilobyte EEPROM with 768 byte free, because we are going to see that there are some disposition inside the memory. So we have a few less bytes inside the memory available to write what we want to write. There is a unique serial number, a 4-byte and a 7-byte. Because of the massive deployment of the card, the 4 bytes UID was not enough for the systems. So they expanded it, the 4-byte UID to 7 bytes UID. The newest MyFair cards have 7 bytes UID. That's a difference between the old cards and the new ones. Okay, so I'm going to show you this. Okay, remember that we have something like this inside the memory, and I'm going to show you this slide in order to understand. So the internal memory is organized in 16 sectors from 0 to 15, okay? Okay, each sector contains 4 blocks. So we have 4 blocks, that's a sector. Block 3 of each sector, okay, 0, 1, 2, and 3, the number 3 is called the sector trailer. That's, for example, this one, or in this slide, this one, the sector trailer, It's being read from the bottom to the top, like every memory, okay? So the sector trailer contains some interesting information about the sector, the sector itself. For example, the access bits and the keys in order to access that sector. So let me show you the other one. Yeah, I'm going to go up. No. Okay, so the access bits are the ones in the middle, and then we have the key A and the key B. 2 different keys in order to access the memory inside the blocks inside the sector, okay? So if you want to read this sector, you will need, depending of the access bits, the key A or the key B. If you want to read or write this part of the sector, you will need the key A or the key B, okay? It will depend on the access bits. The access bits will tell, will fix the reading or writing methodology to access the memory inside that sector. Okay, it's fairly easy. So, and we have a special sector. It's the first one, or the number 0, with a special block, which is the manufacture block. It's the first block of the MyFair 1K tag. So there are in the first, it's fixed. In the first block, you're going to have the information, for example, about the UID, about some internal configuration of the card. It's fixed by the vendor. Okay, so you can't modify the first block. Okay, it's kind of common. So, for example, in this part, you will find the UID corresponding to that tag, and some internal information that the manufacturer burned inside the card when they issued it. Okay? So it's a memory with keys for each sector, and you have access bits in order to let someone trying to read or write it using key A or key B. Okay? So here we have the identification values. Remember the SAC, the ATQU, etc., all those identification values we saw when we run, for example, the NFC list command or the anti-call command. Okay, so remember that we can run it again. Oh no, I have something running. But remember that we had a number 8 SAC, okay, with an ATKA number 4. I don't know if you can remember. So it should be a MyFair Classic 1K tag. For example, the Troika card, it's a MyFair Plus, but it identifies kind of the same. So here we have a little table in order to, for example, identify different type of cards. Let me show you. I will show you how this disposable card identifies itself. I have something running there, but whatever. For example, NFC anti-call. Okay, so the SAC is 18, so it might be, you cannot trust these values in a very, very good fashion, but it should be a MyFair Classic 4K with an ATQ A number 2. So, ATQ, yeah. So it should be a MyFair Classic 4K.
That would be a check.
Yeah.
In any way.
Oh, that's a very good question. We can try to read the memory, but we don't know. That's the main story of it. Okay? We can try to read the entire memory in order to check if it's a 4K or 1K, or maybe we can try to send some deeper commands, for example, using the clock mark, some other type of commands to wake up the chip and to retrieve some other data. Okay? Or maybe we can say, yeah. For example, the thing is that I'm going to show you, I'm going to change, for example, the disposable card, and let's try the anti. This is a 44 with SAC 0. So 44 with SAC 0. It's a MyFair Ultralight. It's there we have a 44 and we have an ultralight. For example, for an ultralight, a MyFair Ultralight, the MyFair Ultralight is not being secured by keys. You can just read the memory. It has another deployment of the memory inside. So we can try to use, for example, the MF ultralight command in order to try to read what is inside the card. So we're going to try to read, of course. I don't know, this one. Okay. 16 pages read. So turn to the next one. So if you, and then it's all zeros down here, right? Okay. So we have this information inside this card. If you download the, I've been trying to clone this card during my work here in Moscow. I have, let me show you. You can try to download the. Let me see if I have. Oh, I don't have. Oh, yeah, sure. you can try to download the specification of the MIFARE ultralight, and you can try to understand. For example, the MIFARE ultralight is kind of different. It's not the same as the MIFARE 1K. Well, you see that it's not protected by keys. It's just a memory. But, for example, this is a 512-bit WD-PROM memory, organized in 16 pages, blah, blah, blah. And this is the part of the serial number. Then we have internal features of the manufacturer. Then we have some bytes called log bytes. And then we have OTP bytes there, one-time programmable bytes, okay? So you can just put it on 1 and then you can just go back to 0. So that's why we can't just reset this card in order to get for example, 2 trips again, okay? So, and then you have user memory. So, if you put this is what you have to do in order to understand what is going on with these disposable cards in your Metro system. I don't know, if you want to clone, is it possible to buy, or is it possible to dump what is inside this card when it's charged with 2 trips, for example, get the memory, and then write it again inside the card? Maybe, I don't know, try it. So I will try to show you. Like this. Let's see if we can understand this piece of data. Okay, so the first 4 bytes are the serial number. Okay, till here, and 4 more bytes till here, and then we have an internal, and then we have an internal here, the serial number here. The internal byte it's here, and then we have 2 log bytes, F0, 00, and then we have 4 OTP bytes, FF, 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 FC. If you try to read a disposable card with 2 trips that wasn't used, you will find that, I tried, you will find that these bytes over here are in 0. So maybe they are just writing FF, 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 FC when the card is used. So maybe you can try to write those bytes into 0 again. And then you have the user memory down here. So using the log bytes, if you keep reading the paper in order to understand what is going on inside there, you will find that, for example, this is the log bytes. This is where the log bytes look like. So we have F0, 0, 0. So my understanding is that we have logged, or the system integrators logged page number 7, 6, 5, and 4. And the other memory is not locked. So you can try to, for example, overwrite the page number 12 and see what is going on. Okay? Or maybe you can try to dump a very new ticket and then try to go back. Yeah.
Sorry, I don't understand. How do you know what page is locked and what is not locked?
Here we have F0, 00 are the log bytes, okay? And then we have, if it's an F it's 1111, okay? So we have locked number 7, locked number 6, locked number 5, and locked number 4. And 0, it's not being locked. And 0, it's not being locked, and 0, it's not being locked. So we only block, or they, no, not we, 4, 5, 6, and 7. And what about the OTP and for example, yeah, the OTP bytes? They are enabled. They have enabled them, us, sorry, to try to put them on 0 again. So maybe we have something here to play with. Okay? Try it. I have some videos. This is not me, for the camera. Okay, 48 trips. Something in Russian that I don't fucking understand. Okay, 48 again. Wait. Can you translate me? What is going on there? Okay. Sorry? 14, yeah, I understand 14. But okay. What is that?
Right there, 49 trips.
Okay. Okay, so some guy managed to crack the metro system. It's on YouTube, this video. So okay, 48 again. So it's fairly possible. So don't try. Well, just for the camera. Okay. And another guy. This is all downloaded from YouTube, eh?
The people told the card with the metro work only in a little time interval because they synchronize with the database. And
With a main backend, and maybe they will deactivate.
They will block this unit of the card, and you will never.
You were trying this for the camera. That's the hacker over there.
I was reading.
Okay, nice. Yeah, very good, very well deployed systems have a very nice backend system. Okay, so trying to identify this kind of fraud. This is fraud, you know. But maybe if you wanna, I don't know, to make some troubles in the same day, in the same interval, I don't know. Maybe you can try, or maybe you can invite the other people. Beep, 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 and then try.
But people say also that the usage of those cards, of those specifically made cards, closed cards, in the past is okay because they are not linked online to the backend. Yeah. Well. That's the story. That's the main story of all of this, and that's the motto that I showed you at the second or the third slide here. You are understanding a system that you don't own, and you're okay. Yeah, the bus is not online, but the metro it's online. So you're doing a black box kind of hack over there. You're understanding the system by yourself, so that's good. So that's another video. This one is really cool. I don't know what the hell he's saying. You're going to understand. Well, he built some kind of piece of hardware there, and he has a valid metro reader. I don't know what the heck. eBay, Chinese guys, whatever. Yes, he's a proud owner of a full-feature metro ring. I don't know what is going on there, but in the description of the video, he stated to clone a car. Okay, yeah.
Попался просто какой-то странный.
Yeah, green light, always green light. I don't know, if you just search for RFID Moscow Metro, you'll find all of this kind of stuff. So you'll find some pretty good stuff over there. And there are many applications in the Google market for example, those Nexus S iPhones with NFC enabled chip, which you can use to read these cards in order to get the trips left inside the card. You can try to, the software will of course read this data and try to understand it, to decode it into some real format, 248 for example, or 2. So you can try to reverse or easily decompile that Android PK, I don't know, the APK, I believe it's APK. You can try to reverse it or just decompile it in order to understand what is going on inside the card and trying to understand where are the bytes that are being used to tell the system how many trips are left inside it. So I believe that those 2 bytes here are the number. I don't know. Try or no, I don't know. So it's you'll have a lot of fun while trying to understand a system that you don't really know nothing about it. Trust me. Okay. So any questions? There. It just go to Google and search for. Let me Google it for you. You know, you can just go to the nxp.com website. That's the manufacturer of the ultralight MyFair card, or just look for ultralight memory specification, or just give me a USB and a USB memory and I give it to you. Okay. Another question? Okay. So you have many interesting systems in Moscow to play with. You know, I want to stay a week or a month in order to understand them. It's pretty good. So, well, if you're going to try to understand them, just shoot me an email. There you have my cards, so maybe I can help you from the distance, or maybe you can just join the Proximar forum where we can just chat over there. So, yeah, there are many. I don't know if you remember. We have the bathroom. If you want to use the bathroom maybe for free, I don't know. You can just get a card for that system and try to understand what is going on. Then if you want to rent a bike, I don't know. There are many. In just 2 days, I was able to find 4 different systems using NFC cards in the metropolitan area of Moscow. So you have 4 and 5 with the metro system to play with. Okay? Of course, only for educational. Yeah. Okay. So, Well, another question. We are just fine with the time, so we are okay. Should we move? Nice. So remember the access bits. There, if you look for in Google for the data sheet of the MyFair 1K tag, you'll find the way the access bits are being used, like the ones in the ultralight card. Remember the F000, those bytes, those bits will log some kind of pages. Okay, you'll find the way that the access bits are being used. There, it's kind of difficult to understand that part. So I found a little piece of software called ACS MyFair Key Management Tool. It's a software that comes with this reader. Yeah, if you buy this reader, this software is included in a CD. It's over there with the drivers, or you can just download it from the internet, or ask me for it. It's okay. It's free. I don't know if it's free. Well, whatever. So you can just select what do you want to protect, what do you want to put, what arrangement you need to set in the access bits in order to, for example, read and write only with, well, this case is, for example, read with key A or B, and write with key A or B. And that's for block 0. You can use the access bits. Remember that each sector contains 3 different blocks. So you will be able to set different keys and different access condition, or read or write, for that current block. So, for example, in this case, we are using key A and key B for reading and writing block 0. Maybe you want to use, for example, you don't want anyone to access, for example, block 1. I don't know, whatever someone is going to use that, but for example, never access that block. Never. Either for reading or writing. Or for example, use only key B in order to read block 0. And it will never be written. Okay? So it's a read-only, it will be a read-only block being used by the key B. Okay? So you will need key B to read the block, for example, 1 or 0. So you can just select all the conditions in this little part of the software, and it will tell you, okay, the new option bits are took, and that's the new option bits. You need to write on where? On the security block, okay? The trailer block. Remember the trailer block, where the access bits are. Okay? It's pretty easy. Yeah? It's easy. Okay. So, did you see how easy was to get the information inside that ultralight card? Because it wasn't protected. The memory was just there, and you can just read it using, for example, the dongle and the libnfc. Okay, but in order to access the MyFair Classic 1K card, you need those keys. So if you want to understand what is going on, for example, inside the Troika card, you will need the keys. So that's the main story of the MyFair Classic cracking or hacking stuff. Okay, so we are going to try to obtain the keys being used inside the card that the readers are using to get the data inside it. Okay, inside the card. So, for example, a very, very simple e-wallet with a MyFair card, okay? With the memory over there, and we have only, for example, we are only using the first sector, and here in block number 2, we are writing how many cash do you have inside it. For example, I don't know, 10, oh, maybe more, 1,000 rubles. It's okay, rubles? Inside it, okay? But it's protected, that block, it's being protected because of the access bits for reading and writing with, for example, key A. You will need key A in order to read or write the money inside the card, okay? So if you try to access that part of the memory, you won't be able because you need the key. That's the main story, obtaining the key, okay? So we are trying to see if some guys managed to obtain those keys in not the very good way. Okay, we are good by now? Yeah? So this is the main story, trying to access the memory of these cards, and then trying to understand what is going on inside, like in the ultralight card, okay? Inside the card there are bytes over there that you will have to understand what is going on. Maybe that's money, and the other part of the block has the, I don't know, the timing information, the time when it was issued by the cashier, I don't know, anything. So we have what NXP states in their homepage. MyFair Classic 1K crypto algorithm is a highly cost-efficient authentication, data and encryption, blah, 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 and sophisticated key diversification technique, and what the hell. Okay, versus we have in the CCC of 2007, okay, 5 years, 5 years ago, 5 years? No, a lot more, yeah? Two guys presented MyFair 6 years, right? Well, a lot of time ago. Some vulnerabilities inside that chip, okay? So, what did they do? Oh, did you see the teeny chip, right? Over there? Well, it's crazy stuff. They used a microscope and they just cut using, I don't know what kind of blades or something like that. They cut the chip in slices in order to understand the gates and the transistors and all those stuff inside there in order to understand what is going on inside the crypto stuff inside the chip by using a microscope of that teeny chip. You know, these guys are really, really crazy. And they managed to understand what was going on inside the chip and inside the crypto algorithm. The crypto algorithm being used by this card is called Crypto 1, and it's not open. The implementation is not open, so it's closed source, and well, you know what happens when someone develops some closed source. Someone is going to try to open it. Yeah. So, what problems, or which problems did they find there? So, search approaches. So, I forgot to mention that that these keys, key A and key B, are 48-bit. Okay, so 6 bytes. So you can try to run a brute force attack over there. You can just move around the 48 bits range and trying to access it. Okay, 0, 0, 0, 1, 2, and moving on, trying to access it. Okay, that's, well, it will take a lot of time. So that's not the most very good method to obtain the keys, because you have the card over there, you have the reader, and you just leave the card over there and leave it running. So trying to access the memory. The question will be, what is the speed of an authentication we can try it, but it's about, I don't know, 50 milliseconds, so it will take some time. Yeah. I will show you later how the attacks work, so we are going to try it. Yeah. So this is the main story here too. Well, I will not talk about the entire crypto and all the stuff being used here, but you know that the most common crypto algorithms use the random number generators. Okay, so the first disadvantages we talked a few hours ago were that poor random number generators inside those teeny chips, because they are passive. They don't have good power in order to process some kind of good random number generation. So the random value being used to init the conversation between the reader and the tag, okay, that seed that will be fed inside the algorithm depends only of the number of clock cycles elapsed between the time the tag is powered up and someone is trying to access it. Okay, so it's not very random then. So if you can if you are able to build some kind of hardware, okay, to maintain exactly the timing between the power up, okay, I'm going to power up my antenna, okay, my system, and the time I'm going to access or try to access the memory of the card over there, if I can keep the timing very, very correctly, I will have the same random number generator. So the same random number. So the crypto will be broken using this kind of scheme. Okay? It's kind of difficult to understand, but well, there is a very, very good paper. Yeah, we have to read a lot, and there is a very good paper I have here that is called, it was written by Noel, one of the guys there, Cryptanalysis of Crypto 1. Crypto 1 is the name of the algorithm being used by the tag. So if you want to fully understand what is going on in the algorithm, why this kind of algorithm uses a random number and all that kind of stuff, you can just read this paper and you will understand. I took a picture from the paper here. This is the gates that are being used inside the tag. They found by slicing the teeny chip this arrangement. It's craziness. So they found that the crypto one, the crypto being used to communicate between the card and the reader consists of a 48-bit LFSR, okay, with a very poor, which we know that it's a very poor random number generator building the challenge. It's a challenge response channel. It's kind of that. So by slicing the chip and trying to communicate with the chip itself, they found this schematic. So they managed to understand what was going on inside the chip and found many vulnerabilities inside there. You're going to take a picture? It's on the paper. Yeah. Okay. Well, so plop. The crypto one was broken and fully understand. Sorry? Yeah.
Is it possible to
To what?
Can we use RFID to this card without knowing the key?
If you can read, it's you are saying that you are asking me if you can read the UID without accessing the. Yeah.
So in this case, you have your ID, then you can.
Yeah, but it's so.
You can know state of mind.
Yeah, it's sort. The plus over there, the sign plus, it's a sort with a random number generator. The UID is that it was broken like that. Yep, it sucks. Yeah. So yep, that's right. The UID, it's let me go back. The first block, the manufacturer block, the one that we can modify, it's fully, you can read it without knowing the key. So you can just read the UID and all those stuff in the manufacturer block, okay? I found some guys of a company while doing my little research of Moscow Metro and just to talk in this class about it, because I believe it, you are here because of this. Some company is collecting the disposable cards on the street, and they are using them to make, I don't know, access control stuff or using the UID. And you have some bytes inside the card that you can write and read. So you can use these type of cards that you can find over there in the street to build your own system, I don't know, to access some door in your house or something like that. It's pretty good. So yeah, there are a lot of stuff here. Come on, it's a memory. Pick it up and use it. I don't know what the people thought while I was just doing like this, trying to collect the cards on the floor. Okay, so again, the main story. We are going to try to attack the MyFair card in order to get the keys and to access the memory. And that's all. Then we have to understand what is inside and what they implement. The Metro guys use the bytes inside it to write the cache left, trips left, I don't know, whatever. So the thing is that we need to know the keys. So we have 3 well-known attacks, not just one, 3. So the first one, it's the fastest one, but you have to use the proxmark in order to sniff a valid trace between a valid tag and a valid reader. You have to put the high frequency antenna connected to the proxmark and then try to sniff a real authentication between the tag and the reader. For example, you have to go to the Metro with the Troika card. Well, the Troika is a MyFair Plus, but let's try to imagine that it's a MyFair 1K, simple 1K, okay? So we are going to talk about MyFair Plus at the end of this. You just go with your laptop and put the antenna between the Metro and the Troika card, and beep, and try to pass. You will obtain a valid trace between a valid reader and a valid card. With that trace, you will be able to obtain the key being used to access the first block, okay? In nothing, in a few microseconds, okay? But you have to sniff, and you have to go to some place without being persecuted by cameras and I don't know, policemen while trying to pass. I don't know, maybe some kind of very far station or maybe in a bus, I don't know. whatever. But you need a prox mark in order to sniff a valid trace between the reader and a tag, okay? That's the first one. And you will have the one key, the key being used to access the first sector, okay? The first sector and wherever block they are trying to read. Okay, we have only one. Or maybe we have default keys inside the card. When the cards are deployed, when the cards are issued by the manufacturer, they come with default keys. For example, all Fs. In order for you to access it and replace it with the keys wherever you want. Okay, so there are default keys inside the card. If yes, you can use nested authentication or the attack implemented in the MFOC software in order to get the other keys. It's really cool. So if you have one key, you will get the others. In this kind of attack will last maybe for some hours, okay? Maybe 1 hour, 2 hours. It all depends. And you are not able to sniff the channel, okay? You have no default keys, okay? So no default keys, okay, get a key. It's called the dark side attack, implemented in the MF Cook software. It will try to obtain one key, because if you have only one key, you will then try to MFOC in order to do the nested attack and obtain the other ones. The thing here is to obtain only one, and then we can have the other one, the other keys. So we can just use the dark side attack that is going to try to maintain the timing in order to do some kind of crazy stuff inside there in order to obtain the key. In this kind of attack, you will need a valid reader and a valid card, okay? But these attacks will only need the real card. There is no need of a real reader, okay? So you can just implement this at home, yeah? So we are going to try them. Okay, so the first attack, the Crypto one, it's called Crypto one. Crypto one is implementation. It's the C. It's written in C. It's the C implementation of the Crypto one algorithm. And because of the algorithm itself, with some of the components that you will get from the valid trace of the nonces that you are going to extract from the valid trace, resetting memory again. Opening translator, right? Done. You are going to be able to from the valid trace get the keys. From the key stream, go back and get the keys. This is called the rollback. We are going to roll back the entire algorithm back to the original keys, from the key stream to the keys, using this stuff. So, this demo is really, really hard to get it working, so, well. For example, this is what we are going to try. I'm going to show you live. This is a valid trace between a real reader. We are going to set some kind of arrangement there with a real reader and a real tag. So this is a valid sniffed trace. We are going to extract some different bytes of it. The first one is the UID. Remember that the algorithm is using the UID in order to fit it. Okay, we are going to use the UID, but it's very well known. You can extract it without the use of a key. Then you have to extract the tag challenge. Remember that this is a challenge response algorithm. So you're going to obtain from the trace the tag challenge over there. Then the reader challenge, the reader response, and the tag response. Okay? And you will try to crack the key using all those bytes over there. Okay? It will roll back the entire state of the algorithm back to the keys. Well, so we are going to try, don't try this at home. We have time, right? We are okay with the time. Oh, well, we are going to try it only one time. Okay. I will use this flat reader with proprietary software, Piki, and I will use the Proxmark. Oh shit, this is a mess here. Okay, I will connect the Proxmark. The algorithm of the software? Of the what? Ah, the readers, yes, of course. This one is called SCL 3711. This is from SCM Microsystems or something like that. And this one is the ACR 122. They are both on the slides. Okay. Okay, I will remove all this crap here. Here, okay. So, I will try to use a test card here. Look, okay, yeah, it's an NFC-enabled card. And I will connect the antenna. I will try to emulate the situation that someone is going to use to sniff a valid conversation between. This one will be the valid reader and this one will be the valid card, okay? That we own. We have the valid card, but we don't have the valid reader like the guy from the video over there. Okay, yeah, connect to Windows and connect the ACR. Okay, ACR2. I will, oh, shit. Okay, so I will connect to the reader. Okay, connected. Reader commands. Okay, get ATR. That will enable you. Okay, this is a MIFARE 1K card. Let's try. Someone asked me a few minutes ago if you can try to understand what is going on inside this card. For example, get ATR. Let's see. It's a MIFARE 4K type of card. Yeah, but it's a MIFARE Plus. We can just get it from maybe from the difference between the number 1 and number 2. It's a MIFARE 4K. Yeah. Okay, let's get the ATR again. So the reader is now connected to the card. And first, of course, we have to load the authentication keys. Okay, let's use all Fs with this test card. Okay, try to authenticate block number, I don't know, let's say 20 with type 8. Let's see. Operation failed. Oh, this one is modified. Let's try another one. This one here. Okay. Again, get ATR, authenticate, block number 2. Let's say. Let's try it. Authenticate, block number 2. Okay. Block number 2, authentication success. Okay, so we have a test card here with all F's in key A, and we just access with that key to the block number 2. And authentication is success, so you can just read it. Okay? And this is what it's, oh shit. This I don't know. Well, we'll close. There. There. There's LTR. Authenticate, block number 2, for example, anyone, okay, success. There, all zeros, and with, for example, an ID over there. Okay? So, memory block success. We are going to try to sniff that authentication sheen. So, run the Proxmark. So we are going to try and check for TA. Snoop. We are going to eavesdrop that conversation in order to get the bytes that are being sent between the reader and the card. I don't know if it will work. Can you see when when doing this with the same laptop, it just collides everything. We have to, you have to put the antenna between. For the very, to get the full conversation and to get the exact bytes, you will have to put the antenna between the reader and the right and the reader and the tag. Okay, you can try to put the antenna over the card and with the card between the antenna of the Proxmark and the reader rod. For best results, just put it all like that. Okay, so we are going to do it faster. So we are going to look and try to read. Oh shit. Again, because I remove it, you know. Authenticate, block number 2 here, and we are going to snoop it again. Okay, snoop, read value, read number 2, read. And it's still snooping. You can just press the button, command finished. And now you can try HF 14A and list. And let's see if we have some, maybe here. You will have to search for, here. Remember that we are going to use the UID and some challenges. So let's see if we've got something here. Come on. Okay, we need something like that. Like the UID being sent, and then some kind of this arrangement of bytes over there. So let's see if we have something here. Let's try to see which is the UID of the card, okay? Just to, the UID is, get ATR, and we can just authenticate, for example, block number 0, and read block number 0, Okay. This is the UID, right? 3B, 8F, 8180. Okay, let's try to find in the trace of here. It's 3B, something like that. So, is someone being able to read it over there? Because I don't. Let's see other trace here. No, no, no. We have something only there. Well, we failed. We can try again. Only one more time. Let's try again. Let's try to authenticate block number 0 and then snoop and read number 0. Okay, snoop, button, and list. Let's see. Okay. Maybe I'm wrong with the, I will use this, the NFC list is better. Oh, sorry, the UID is DD-B982, I was wrong. DD-B982-19. Okay, so let's look for that. DD-B9. There.
The last string.
Where?
The last.
Oh, here. Let's see if it. Yeah, but no. Have no. Well, one more time, and this is the last one. Trust me, it worked. It works. Yeah. I'm going to read. Sorry, list. Now I will try to snoop again. Snoop. Authentication success. Stop. And then list. Trust me, huh? Again. Well, one more time. I want it. Read. Took. It's very difficult to show it in the same laptop because of the interference between the Proxmark, the antennas, and all this stuff here. But trust me, it works. It works. Sorry. Okay, DD, and what the hell? Ah, shit. What? Trust me, it worked. Try it at your own home. Or maybe later we can just go in another place, I don't know, in the living room over there. I can show you later. But we have to hurry because we have 40 minutes. 20 minutes more. 20 minutes. Okay. So I will show you the other attacks. Okay. Maybe you can join me later in the living room over there, so we can just try to crack the system. Well. Okay. So if try it and trust me, it works. So then we have two different implementations of the attacks. We have the mfcook and the mfoc. Okay. So you can just download the software over there and those URLs and try to run the full card-only attack, or the mfoc trying to with one key obtain the other ones. Okay? So what we are going to do is to try obtain one key with no valid reader and recovering all the keys with only one. We are going to do all the stuff in just one step. So I'm going to disconnect the flat reader and use the SSL 3711 because it's the best one it's the best reader writer in order to run these kind of attacks. So I'm going to use the Troika card, okay? Connect to Mac. I have here, okay? So, MFOC, okay. I already compiled the MFOC, it's pretty easy to compile it. I will show you one slide with all the steps needed to compile all this software if you don't know how to do it by your own. Okay, so if you just read the fucking manual command, you will find that it's pretty easy to run. You will have to run mfoc with this parameter and the file that will be written with the data inside the card. In the case you are able to obtain all the keys and you are able to read all the sectors with success. Okay? So I will try. If we can, I'm going to use the Troika card. Okay? Remember, if we are able to obtain one key, we are very lucky because we are going to. It's fairly easy to obtain the other ones. Okay? Just remember that. In my for 1K type of cards. So I'm going to use this dummy command. The mfoc, what I didn't say is the mfoc. Remember that the mfoc is going to implement which kind of attack? The nested one. The one that you already own a key, okay, to obtain the other ones. But if you run it like this, or like this, it will first try the default keys, yes, in order to obtain one sector using default keys. If it succeeds doing that, it will try to get the other keys using the default ones. Okay, that's pretty good. So we're going to run the full attack right now. So, can you see my authentication failed because it's trying many different keys. So it will try to find one default key in the entire memory, and then use that key in order to get the other ones. Okay? So let's see if we are lucky. Okay, it's using another default key. There are many default keys. For example, FFFFFF, A0, A1, A2, A3, A4, I don't know, 0, 0, 0, 0, etc. There are many well-known default keys. So, by the end of this, yeah, sure. There. Yeah, this phase of the attack, it's not a brute force, it's a dictionary attack. Because inside the software, they have coded, I don't know, 10 or maybe 15 different default keys, and it's just trying to access the memory using them. So, look, we are kind of lucky. We have found in sector 1 the key and the key for sector 2 and the key for sector 3 and the key for sector 4. Unknown key, unknown key, unknown key, okay. And many other keys to read it. Okay, so in the second phase of the attack, the software will try to recover the other keys. So you have to leave it running and running and running, okay? Maybe just a night, I don't know, kind of time, okay? So by the end of the whole attack, you will be able to obtain the entire keys and then extract what is inside the memory, okay? Again, this is a MyFair Plus card. So this is a new version of the MyFair 1K. It's retro-compatible. I will show you one slide with the neat new characteristics of these cards. So these kind of attacks won't work. So don't, well, maybe yes, try it. I don't know. Okay? You are like this. What do you want to say? There. Oh, yeah. It's the distance between, it's trying to get the nonsense between the communication between the tag and the reader, and it's the vector distance between them. It's kind of difficult to explain in just 2 minutes. If you want, there is another paper, if you want to understand what is going on in the attack. Well, regarding the other piece of software called MF Cook, there is a paper called The Dark Side of Security by Obscurity. That's why the attack is called Dark Side Attack, because of the dark side of security by obscurity, you know? So this paper is really good to understand what is going on there. And there is another paper. This one is neat, really, really cool. It's called Practical Attacks on the MyFair Classic. They are all in the files section of the Proxima forum, I thought. Or try to maybe I can show it later, just to write down the name. But it's a paper written by a guy that for his degree. So it's very well explained. He explains the crypto one algorithm very well about the pseudo random number generator, why it's leading the same random number over and over, the key recovery and the attacks that we covered here. Well, he explains all the attacks here, and he developed his own software. I tried to contact him, but with no luck. Trying to obtain his own pieces of software. So, well, it's called Practical Attacks on the MyFair Attack. It's cool. So, well, so we have 3 main attacks that we can use in order to obtain the keys and extract them. Of course, for MyFair 1K or 4K Classic. So, yeah. Necessary information. Recover keys with a valid reader, the first attack. Then another publication from Flavio without obtaining, it's escalating from 1 key to any without a valid reader, the MFOC software. You can read about this attack and what is going on between the distance and that kind of verbose information. Try to read that paper, it's really good. And the common prefix attack that retrieves a key without a valid key or a valid reader, okay? This is called the dark side attack, okay? So, these papers are in Proxmark files format. Cool. So, you have many information there. So, remember that I said that the first block is fixed by the manufacturer, okay? So you can't modify, for example, the UID because it's on the first block, okay? But charan charan, some Chinese people. I don't know when, there, yeah, the post, 23 of July of 2011, yeah, I've been researching this for 2 or 3 years, and he registered the same day as he posted this. So we all thought that it was just junk or some kind of spam in the forum, but he stated, we supply the cards below. Works exactly like the MyFair S50, that's the MyFair 1K classic tag, with 16 sectors for block, yeah, the MyFair 1K. But the manufacturer's block, or block number 0, can be reprogrammed to any ID you wish. So it's very useful. These type of cards were very useful in order to, I don't know, to clone. For example, if some system is using the MyFair 1K tag in order to authenticate, like the ones with low frequency. Remember that in order to authenticate to a low frequency system, they are only transmitting the UID. So you can use this type of cards in order to clone the card. Okay? So it's advantage, it's Chinese, yeah. This is a perfect solution for a loss of a micro, blah, blah, blah. So we all thought that this post was just spam. But I told the other guys, yeah, I will try it. I will try to buy only 1 or 2, because the other thing is that the guy in another post said, no, the card was about $20, so it was just expensive. You know, the typical MyFair card, it's $1, so $20, it's 20 times more. So no, I can only send you from a quantity of 10, I don't know. So, well, 10 times 20, $200 that I will not know where it's going to be. So, can you? Yeah, I'm the owner of the Proxmark forum. I'm an admin. I don't know. Blah, blah, blah. If they work, as you mentioned, we are going to buy more. So come on, try to send me only 2. So I bought 2 of these cards, trying to see if it was all this real. So yeah, finally the cards arrived to my home, and yeah, the manufacturer block, we were able to reprogram the first block. So we were able to change the UID. Many systems use the UID in order to, I don't know, to encrypt the data inside the memory. So if you are able to, if you want to do some kind of understanding of what is going on inside a car, you can try to change the UID, I don't know, from the number that is fixed to all zeros, and then try to authenticate or try to travel using the metro, for example, and see what is going on with the bytes left by the reader after the transaction, okay? And then you can just, I don't know, set the UID to 1, and then to 2, and then you are going to manipulate the UID of the card in order to get some results that will help you to understand what is going on with the transportation system, for example, okay? So, or maybe they are just using, for example, in the university that I own in Argentina, they are using MyFair cards in order to pass through the pedestrian barriers in order to access the building. They're using a MyFair card. I don't have it here, but they're using a MyFair card, and they are using the UID as the identification number that will let you or not pass through the barrier. Okay, so I can just sniff someone's UID with any reader, with a very cheap reader, okay? And then use these kind of cards to put the new UID and access the building as the other guy, okay? So, magic Chinese cards. Okay, so good news from NXP. As I told you, there are newer MIFARE Classic cards. So they don't leak all those nonces and acknowledgements anymore. Those NACs are being used in order to reverse the algorithm and obtain one key from others. They don't use the 16-bit LFSR anymore. The NXP changed the way they are encrypting. There is a true random number generator at startup, so that by fixing the time, you are not going to obtain the same nonce. So that's the main attack, you know. But still remains. They are still using the Crypto 1 cipher. So, well, we have some tweaks over there, but because of retrocompatibility, they didn't change that. So that's where MIFARE Plus arrived. So MIFARE Plus will replace the MIFARE Classic shim to provide more security. By the mean of what? So we have, well, now the Tiny chip supports AES, so pretty good security over there. You can just random. Remember that when the card identifies to the system, it uses its own ID. Every time it passes through the field of the reader, it will emit the same UID. Well, they changed that in order to provide more security. The card itself will identify itself with different UIDs, just to provide also a random UID generator to the entire algorithm. And of course, all those attacks I showed you won't work. So, and it's retro-compatible with MIFARE Classic, okay? But, for example, if you're using a MIFARE Plus with all default keys, game over. You have access to it, okay? So, well, if you're using MIFARE Plus, try to set all the keys to another ones than the default, okay? We are doing time? 10. Okay, we are just closing. Okay. So, okay, use cases and real world hacks. We are just finishing. Okay. Yeah. In Argentina we have the transportation system using MIFARE Classic 1K. So it's possible to run all these attacks I mentioned, okay? So if you find, for example, if you just go to, I don't know, Canada, the M card, it's using a MIFARE Classic 1K. Some guy over there told me that in some transportation system in a little town near here, they are using a MIFARE 1K too. So you can just ask the wiki, and then you have over there many different countries with their own implementation. Then you have to understand the implementation, right? I mean, you have, okay, I have the keys. I can access the entire memory, but then I have to understand what is going on inside. But if it's an e-wallet, you know, and there's, for example, and it's online. Okay, it's an online e-wallet system, and they are using MIFARE 1K, and and the money is written in some of the blocks over there, and you were able to access the entire memory. What's the attack you are going to try at first? It's a new wallet. It has money inside the card, and it's offline, for example. Okay, I have 1,000 rubles here, and I will use it. I can read it, and I can write it back again. Okay, so which is the stupid attack that we are going to try against that system? Ideas, ring the bell? The backup one. I will try to, I will put 5,000 rubles inside my card, read it and dump it. I will use it and will write it again with 5,000 rubles again and will try to use it again. If it's offline, if it's all kind of messy, you will have 5,000 rubles every time you're going to use it. So the backup attack, it's, okay, you don't understand what is going on inside the card. They are all just bytes inside there, but you know that there are 5,000 rubles inside it. Okay, so well, just backup it and try to recover the money inside it. That's an idea, okay? For 1K or 4K? At Classic. MyFair Classic. In case you have the key? Yeah. Yep. You can try the backup attack. That's an attack for the implementation, you know? We already recovered the keys. We run everything. Now we have to attack the implementation itself. Okay? So the backup one, it's the most stupid way to try and to test the implementation there. Don't try. Sorry. Well, this is not new, you know. In the Netherlands, the OV chip card, it's the transportation system in use there. Some guys from the University of blah 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 managed to crack the transportation system in order to manipulate the content, clone the card, I don't know, do the backup attack in order to travel forever and ever, and etc. And in October 2011, the company responsible of the OV chip card announced that the new version of the card will be better protected and against fraud. And yes, I've been in the Netherlands in March, I tried to crack the card, and yeah, it's this fire, I believe. It's a new version of the MyFair. It's another type of MyFair card. And there is another case with the Oyster card in London. Okay, another hack of another transportation system. Well, it's very well known. It happened a few years ago, and the response from the guys from the Oyster card said, "We will carry on making improvements to the security of the Oyster system." I don't know. Maybe they implemented a really good backend in order to detect this kind of fraud. Okay, same UID, same money. And okay, again, same UID, same money. What is going on? If it just travel once, and then again the same money without really putting money inside it. Okay, so using with our very, very good backend system, you can try to improve the security of an entire deployment of this kind of stuff. Well, in Buenos Aires, Argentina, they are using MyFair 1K too, So there are many different readers in the buses. There's a tip over there. For example, I found that there are a lot of RFPs from the government asking for vendors to sell their systems, and you will find in all those papers that are very public, because you can just go to the government website, go to the we are buying this stuff, and you can just see what is going on in your government, and you can find a lot of information of the system that is going to be deployed. For example, I found that we are trying to build a system using My401k. There is a lot of technical information about the system that is going to deploy. Then you will find a lot of deep information regarding the system in all those RFPs that you can download from the internet. Then, for example, there is a system called Monedero that is also using a My401k. Monedero stands for it's like a new wallet where you can buy, for example, books or I don't know some stuff at a kiosk or whatever you want. Like micropayments, no more than it's 2,000 pesos. That's $20, for example. It's meant to be for micropayment stuff. Okay, so they are using My401k too. So someone could try all these attacks. Could be trying all these attacks to the system. And well, those are, this is the metro from Argentina. The picture over there it's a picture from the metro over there with those pedestrian barriers stopping the path, the way. Okay, so every morning I just go down the stairs over there and pass through there. But if someone checks in twice, the pedestrian barrier will not reset its state. So it will say, okay, I have to leave two trips for people to pass. So this is a picture taken from the other side where you can just you just passed through it. This is okay. You can just take the metro here, but from the X here, it says, okay, you cannot go back. Okay, there is a freeway here. So if someone checks in twice, you might have some free passes over there. So, well, that's pretty neat. Finishing. 2 more slides. Okay, so cool stuff, resources, tips, ideas, and cheers. Just to say goodbye. Okay, so everything you need to know to look like you know everything. So you have Proxmark links over there, tools over there, My4 information from the NXP and the wiki over there. The 3 main attacks we used, Crypto, MFAC, and MFOC. And if you want to do some shopping to get all those neat pieces of hardware, they are all well-known resellers. So I will not. So you can do some shopping because you will need all those hardware tokens and flat readers over there. So you can buy those shields in Identity Stronghold. That's the trademark for the shields to protect your card. From Havacard or JavaCard SDK from Futako, you can buy these kind of dongles. It's a very trusted reseller. From RFID shop in Hong Kong, if you mention the workshop, you will get a 20% off. Well, whatever. You can buy the Proxmark from the real site, the original site, from proxmark3.com, Or maybe you can try it like the guy over there. I don't know if he left the room, but he bought the Proxmark from the last resource from xfpga.com. He's a Chinese guy who owns a company making hardware, etc. So he's the member of he's a member of our forum, so he's a trusted reseller to Smart Card Focus to get this one, the ACR. Well, we all love shopping. Okay, so last slide. One more? Give me more. Okay, we didn't talk about everything regarding RFID and NFC. We can just talk, I don't know, 5 or 10 days about it. So, for example, there you have the Me command line utility based on libNFC, which allows to interactively manipulate MyFair Classic tags. If you want to manipulate all those MyFair Classic tags, you can use the Me command over there. You can buy an Arduino, for example. I'll show you here. I'm just finishing, huh? Trust me. Like the first attack. Okay, this is an Arduino, for example, with an LCD screen on it, and there's a shield over here that is NFC enabled. It comes with PM 5321, so it's you can just program your own stuff here. For example, if you want to read how many trips are left inside the car, build your own Arduino software, plug a little battery. Okay, it's on. Welcome, and I put this one, and I will read how many trips I have. It's pretty easy to write your own software on Arduino. So there is a shield for with NFC enabled stuff for Arduino. The entire stuff in Deal Extreme, it's about it's $50, less than $50. So it's pretty good stuff to have too. Well, many other different cool stuff. Check RFID stuff. There are many different resources on RFID website. Well, the e-passports with NFC enabled chips. We have many vulnerabilities over there. You can just check the THC website in order to understand what is going on with the e-passports with NFC enabled. That's why you will have to use the other. Where is it? I don't know. I have a mess right here. Here. That's why we have RFID blocking secure slips for passports in order to not get caught and gift my identity, I don't know, over there. Tomorrow you will have a talk about privacy and those kind of stuff using RFID and NFC. Tomorrow noon, I don't know. It's Show Me or that, I don't know what's the name. So, well, another stuff over there. You have, okay, use the source. There you have all the steps in order to compile all the stuff. Okay, libNFC, MFCOC, and MFOC. And then there you have some, okay, for Mac. Well, it's kind of similar in Linux. Well, try your best at the other operating system. Okay, and there are many other attacks that we didn't cover. For example, what about Google Wallet, I don't know, or steal information from RFID-enabled credit cards? Okay, maybe someone is sniffing my credit card information just while he's passing near me. NDEF hacking. Take a look at NDEF hacking. It's really neat. For example, NFC phishing attacks, NFC touch attacks. Those NFC-enabled posters, like this one, for example, NFC Net Store. This is a poster that you can just plug paste it on the street, for example, in order to do some publicity of your company, for example, and then someone with an NFC-enabled phone will try to read that tag, and then it will, with NDEF, sorry, I have to reboot again. With NDEF hacking, you are going to forward the victim browser to maybe some phishing site or something like that. So check NDEF hacking, it's really neat. Quick and dirty countermeasures, we don't care. Okay, so, well, special thanks to PHDays crew of Field 2, and it's a friend of mine. People from Proxmark, join the forum, ask whatever you want. So they are, all questions are very welcome. It's a very active forum, okay? So, well, and researchers, the real researchers who slice those chips and understand all the deeper stuff, and who share all their knowledge. That is the one of the mottos we have, to share what we know. So, well, thank you for listening and staying. And well, we have questions. Hackers gonna hack? Try it yourself. Buy some stuff, and then you have many NFC-enabled devices near the Moscow metropolitan area. So play with them. Obviously, educational stuff. So that's all. And thank you.
Thank you.